Hello, everybody. This is my capstone project. This is Joshi. Um, the topic of my project is seeking unified data solutions in big data, machine learning, and blockchain. And this is for the capstone research project, MSIN 695. In my project, I did an extensive review on big data, machine learning, on big data and blockchain for big data, and find out how we can work and unite these three technologies that are otherwise being worked upon in silos. Uh, so in the first part, I'm going to take you through the machine learning solution that exists in the big data world, and Scala and Spark is like the most common uh, infrastructure and architecture that is being used in the literature. Spark is an in-memory database, and it's like 6 to 10 times faster than the traditional MapReduce that used to work on Hadoop because of its in-memory aspect. So machine learning is mostly done on Spark using Spark libraries. Most of the research that I looked at were using Spark, which is the fastest way to do machine learning. And Scala is a language that is both functional and object oriented. So it runs on Java Virtual Machine, and that's why everybody is preferring Scala, which is as easy to write as Python, but on the back end it's as fast as Java. Um, the architecture of Hadoop is MapReduce. So each job converts into a map and a reduce step. So when we want to run machine learning or implement any step, then we have to keep a track of that. Yarn is the operating system of Hadoop, yet another resource negotiator. So Yarn is going to take the job and submit it on the cluster. Now, Kafka becomes important when we are trying to integrate everything, because most of the data that's going to be injected when you want to look at a unified solution would be coming from IoT. So Kafka can use streaming data from IoT, whether it be health or finance or your car data or your house data or your food data, whatever data that you want to quickly inject into the Hadoop cluster. So speed is important, and Kafka also can take care of the locks. So if you want to put a lot of locks on the Hadoop cluster, big amount of locks, then Kafka could be used. To secure everything, Kerberos is the standard that has been used in Hadoop, and I reviewed and found out that Cloudera and Hortonwork both are using Kerberos as a way to secure communication, which I have proposed in my unified solution. A blockchain is like a public database. It stores data that could be publicly accessed. A part of data is public, a part of it is private, and we have to pay money to do that. But it integrates and rewards people who do something or who contribute to it, and it costs money to read data from the blockchain. And and my research talks about integrating machine learning, Hadoop, and blockchain. So right now we are storing data on Hadoop. It's very hard to run machine learning on that using TensorFlow or Keras or other machine learning libraries through Scala, because the data is unstructured and we have to clean the data, and Spark is used for finally running everything. But we have no incentive for people to share their data, and privacy is a concern. So monetization can be very well done by blockchain, where we can reward people to share their data and reward people to run machine learning algorithm or contribute their computing resources to have this big data architecture. So using data, storing data, and monetization in one single infrastructure or architecture has not been achieved. So that is what my research has been on, how to bring them together. So I told you about Spark, which is the main language for machine learning on Hadoop. Liu did Spark on Hadoop and tested like the speed of Spark, and found like it to be 6 times faster, which I've shown in my paper. And Aurora and Varshney also did K-mean and K-meanoid transaction using Spark machine learning library. And these kind of things cannot run on SQL or Python as on the traditional stuff. So Spark is a functional programming language and an object-oriented, and it's similar to Python. The big data architecture has Hadoop file system, which is a distributed file system where data is distributed among different nodes. And Yarn is the operating system or the resource negotiator. And N et al. Has described multi-job workload using a resource-aware schedule. And this kind of research is important that we have to integrate in the solution because there would be no human intervention, which is also one of the weakness. And Wonka has showed the importance of OZ, which is a scheduler, and Zookeeper and Avro. Zookeeper is going to track everything from start till the end, and it goes across different architecture. So Kafka is a publish subscribe model. Streaming data from IoT or sensors can be ingested into Hadoop file system using Kafka. The data starts from the sensors or the IoT, or if it's a self-driving car, then from the car. If it's health, then it's from the gadget, or any other information, logs or financial data. And Kafka can integrate very well streaming data and live data or real-time data into Hadoop file system. The APIs are written in Java. Now Kafka and Hadoop, especially Kafka, gives us the Zookeeper, which takes care of the data, and from the point the data is created to the point it is stored in a structured manner in Hive, which is a SQL styled way of storing data, structured data on Hadoop. It takes care of everything. So Zookeeper could be assumed as something that take care of everything from the starting till the end. Now, when we come to blockchain, right now the S. Samali, he talked about the application of blockchain and the current blockchain that enables us to use computer, or which allows people to share their computation power and hard disk, which means that they can give their computer and get money in exchange for that, is EOS. In the Bitcoin and Ethereum blockchain, you solve a puzzle and you get rewarded to create a block or to sign off a block. But EOS is more like sharing your whole system or computer. And what I have proposed is that if we can use EOS and Hadoop and Kafka, then we can create a unified solution where EOS would actually reward the token to people who are going to run machine learning and token of people who are going to share data. And it's going to cost money for people who want to run those machine learning algorithms. So if you imagine, if we have people who shared their data about their health and heartbeat, and that was used to run a machine learning algorithm that predicts heart attack based on your heartbeats of like 10 days or 15 days and other stuff. And if somebody wants to use that data and use the machine learning parameters, then he has to pay. So there is no central party, there is no private entity in between. The users get rewarded. The people who share the data and share the resource get rewarded, and everything remains in the public. So blockchain makes that possible. Like Bitcoin blockchain allows us to send bitcoins without any transaction fee. That's why we don't need to pay a spread or a bank fee. So it's like we take out the middleman by using blockchain. So when we talk about EOS, EOS is like an operating system level blockchain, and it can create massive decentralized application. And Hadoop is a distributed database. So the marriage between two is what I'm proposing here. Now the security aspect is important because whenever a node wants to talk with the other node, they have to verify whether that's right. So for that, Kerberos is used. Kerberos is talked about extensively in the literature when we see implementation, and Hortonworks and Cloudera has talked about Kerberos and how we set up. And Vivekanand at etc. all have discussed about how Kerberos helps for the secure transfer of data. This is my proposed algorithm that I'm proposing to integrate all of the three. We need to create a zookeeper. We can borrow this idea from the zookeeper that is used in Kafka. The zookeeper is going to keep a track of data that's going to get generated from IoT or any other place, and it's going to keep a track on how the data gets stored and how the machine learning guys use it. So the complete process could be tracked by zookeeper starting to ending. And tokens would be rewarded for people who contribute their data, and tokens would be rewarded to the machine learning resource data who are going to give that resource for running machine learning algorithms, uh, complex algorithm for that. So in conclusion, if we were to integrate everything, we need to look at EOS, which is right now the size of that blockchain is like a few gigabytes. I'm proposing that we could still use, based on some of the literature, 12 node cluster that could support like 5 to 15 terabytes of data. That should be big enough to start with. To test this data, I'm proposing we use AWS Elastic MapReduce or DigitalOcean and mount Cloudera for now to test it and make the prototype. The tokenization of data from IoT will incentivize people to share their data, and the tokenization from Spark machine learning side will help and motivate people to run the machine learning algorithm and share their resources with us. Uh, and since Hadoop in itself is distributed and replicated, some people can come in and join in. One of the challenges is that joining new people is going to be harder because the data is big, so the network speed is going to slow things down. So that's one concern. The other concern is privacy. People who want to share their data are concerned about their privacy. And the other concern is the deadlock of processes, because in Hadoop, if something is not working, then there are Hadoop admins who take care of that and kill the job or restart the computer. But if it's completely automated at a blockchain level, then those algorithms have to be automated, where if something is not working, how do we do that? And since Hadoop is not that mature, a lot of time when there is a problem, you have to manually kill the job or configure the containers and all the memory allocation on how you want to allocate memory for different processes. So a lot of things in Hadoop is not yet automated, and things get stuck in between. So when we create a unified structure and there is no human intervention and everything goes automatically, we need to find a way to make sure that if we receive a deadlock, if some process locks some resources and other process wants to read it, then how to release that. So that is about my finding, and then I have the references that I have used in this paper. I hope this was useful, and thank you for watching my presentation.